Okay, so in this video we're going to be looking at distance time graphs. Now we're going to be looking at all sorts of things to do with distance time graphs, reading them, redrawing them, interpreting them, and we're going to be building up to the kind of question that you can see on the screen. So throughout this video you are going to need to have an awareness of speed, distance and time, so I will obviously link that video in the description as well, but with that being said, let's get started. Okay, so we're going to start off by looking at one of the easier styles of questions. So if you have a look on the screen, you can obviously see that we have a distance time graph. And whenever you have a question like this, it's always very important to read what's on the axes. So up the top here, going up the y-axis, we have the distance from home, and down the bottom we have the time of day. So if we go through and read the question and see how this all relates, it says in the question that James cycled from his home to the park, he waited at the park and then cycled back home. And we can see that going on the distance time graph. We can see just here that his distance increases as the time goes on, as his distance goes away from home. We get to the peak here where he stays at the park. He stays at the park for that period of time and then he cycles back home, and you can see it all going on within the distance time graph. It then says in the question, what time did James leave home, what is the distance from James's home to the park, and how many minutes did he wait in the park? So all we're going to do is we're going to read each part and we're going to have a look at how this could be interpreted on the distance time graph. So starting with part A, what time did James leave home? Well, he left home at the very start of the graph, and you can see down at the bottom here, this is where his journey started, and just there is the time that it actually began. So if you have a look, that is between 9 o'clock and 10 past 9. So right in the middle of that would be 9:05. So in terms of what time he left home, we would just say he left home at 9:05. Now obviously it doesn't say here what format the time has been written in, but that we would assume that it's been written in 24-hour clock, and that is 9 in the morning. But it doesn't ask us to give it in terms of AM or PM for this particular question, so just giving it in the format that it's given to you on the axes is absolutely fine. So there we go, that would be part A, again just reading what time he left. Now moving on to part B, it says what is the distance from James's home to the park? Well, we discussed that at the start. This is his journey from his home to the park. So when it gets to this point here, at the peak of the graph, just there, that's when he's arrived at the park. And you can see that he's arrived there because we have the flat line, which means he's not going any further distance. So he is stopping in one place. So in regards to the story, that will be when he stops at the park. So in order to find that distance, we obviously want to read off the y-axis, which is showing our distance. So very carefully, and I would suggest getting a ruler and just putting your ruler across the line there, because we want to trace along to the side of the graph and read which number this is. And that's quite a nice one because it lands perfectly between the 6 and the 8 there, and we know that that number is 7. So in terms of the distance from James's home to the park, that will be 7 kilometres. And there we go, we've read a distance as well. It also says on this question then for part C, how many minutes did James wait at the park? So if we're looking at how many minutes he waited at the park, then we are going to read that flat line. And the flat line there, if I highlight it, is when he stayed at the park. Obviously beyond that is when he's cycled back home. So in order to read how long he has stayed at the park, we want to know when he started at the park. So if we go down from the start of that section, that's going to give us the time that he got to the park, which is in between 9:30 and 9:40, so that is going to be 9:35. And we also want to read the time that he left the park. So if we go down from the point there, that is going to land in between 9:40 and 9:50, and the answer for that is 9:45. So in terms of how long he spent at the park, we're looking for the time in between that, which is from 9:35 to 9:45, and that is a total of 10 minutes. So the answer for that, we would say 10 minutes. And that is how we are going to read information from a distance time graph. So hopefully that was a good little overview of some different things that we could read from a distance time graph. Obviously in the later part of this video we're going to have a look at some slightly trickier parts to this, but to start with, your first question is just going to be having a look at reading some information from a distance time graph. So let's have a look at one of those questions now. Okay, so here's your question. So pause the video there, have a read through these parts of the question, and we'll go over the answer in just a second. Okay, so it says Anna went on a cycle ride. The travel graph shows Anna's distance from home on this cycle ride. And then it asks us some questions. So we can see from the graph she goes on a cycle ride, she has stopped somewhere, and then she has cycled back home. So we can obviously now answer some questions based on that interpretation. It says, how far had Anna cycled after 30 minutes? Now this is quite an interesting one because on the previous question it was how far until they got to the park, which was the total distance of the line here, which as you can see just to the side is 12 kilometres. And we might be asked that in a later question, but this question has only said in the first 30 minutes. So after 30 minutes we needed to be very careful here because 30 minutes is only part of the line. So you can see that 30 minutes is down here between 20 and 40, and if we want to read the 30-minute distance, it's only up to this point on her journey. And if we go across from there, that is 6 kilometres. So after the first 30 minutes, she had only actually travelled 6 kilometres, not the total distance where she got to her stop, which would have been 12 kilometres. So it then says after 60 minutes, Anna stopped for a rest. And we can see that as we go up the graph, we stop here and that lands on 60 minutes. And again, you can trace down just to make sure, and that is the 60-minute point. So we're happy with that. So let's get rid of some of this and let's think about this question. So it says for how many minutes did she rest? So now we are looking at that flat part of the line like on the previous question, and that goes along 2 of these squares. So if we want to read that, let's again think about the time. It started at 60 and it ended at 80. So that distance between 60 and 80 is a total of 20 minutes. So for that part of the question, we would say 20 minutes. And that's that part done. On to part C. To finish this off, it says, how far did Anna cycle in total on her ride? So obviously something slightly different here to what we went over on the previous question, and you will notice that there's quite a lot of little differences in every single question, but hopefully you'll have had a good go at this. So in terms of how far she cycled, well, in the first part of her journey, she cycled 12 kilometres. She then didn't cycle any further distance as she obviously had that wait in the park, but then she did cycle home, and that distance there is going from 12 kilometres back to the beginning, which is another 12 kilometres. So in total, she cycled 12 on the first part of the journey, plus another 12, and that in total is 24 kilometres. And that would be the final answer for this question. So there we go. Obviously there was some slight differences in that question there where you had to interpret the graph with slightly different ways, but combining the last question with this one, you should now have all the information that you need in order to access any interpretation questions on these distance time graphs. Now what we're going to do is we're going to introduce looking at speed in this, so let's have a look at one of those questions now. Okay, so we've got a little bit more to this question, and as you can see there's quite a lot of information. So again, let's just have a little read. It says Julie drove from her house to the airport. She waited at the airport and then drove home, and this is her distance time graph. So you can see obviously it looks very similar to the previous ones. So for part A here, it says what is the distance from Julie's home to the airport? So that part there we can read nice and easy. We've got the top part here, and we're going to read that distance, which we can see is 40 kilometres. So we'll write that as 40 kilometres, and again, all these questions are in kilometres, but do make sure that you read the axes because it does say the distance in kilometres. Again, this question here is about the time of day rather than minutes down the bottom, so we actually have to interpret the time. It then says how many minutes did Julie take to get home from the airport? So in terms of getting home from the airport, that's not about the time that she waited, but it is about this distance here, or this journey here. And you can see that when she left the airport, we can get the time, and that time is just down here, that's 3:30. So that's the time that she left the airport, and obviously at the end of the journey, she gets home at 4 o'clock. So in terms of how many minutes it took for Julie to get home, that goes from 3:30 to 4, and that is half an hour. So in minutes, that would be 30 minutes. Again, reading the question carefully, it does say how many minutes, not just how long, so you do have to give that in minutes and not saying half an hour. It then says for part C, and this is our new part here, it says work out Julie's average speed on her journey home from the airport. Give your answer in kilometres per hour. So in terms of working out an average speed, we need to remember our speed distance time formula. And we have all the information already in order to work that out, we just need to be careful when we're using it. So our speed distance time formula is that speed is equal to distance over time. And remember, if you like, you can put that into a formula triangle. So if I write the formula triangle over here, that is that speed is equal to distance divided by time. Now we need to be careful on this question because it does say to give it in kilometres per hour. And for the previous part, we just wrote down that the time was 30 minutes. And when we are working with kilometres per hour, we need to make sure we write that in terms of an hour. So we'll discuss that in just a second. But let's think about the two bits of information. So we need the distance. Now the distance at that point on the journey, we've actually already written down. We've got that was 40 kilometres. So we know we're going to do 40 and we're going to divide it by the time. And the time we have already got as well. We have got the time from this part of the journey down here, which was 30 minutes. But we need to write that in hours. Now this is not a nasty amount of minutes to write in hours because you should hopefully know that that is half an hour, which can be written as 0.5. But if you are struggling on one of those, particularly if it's a harder amount of minutes, then you need to know how to turn that into an hour. And the way to do that is just to write it as a fraction. So we think about an hour, which is 60 minutes in total, and here we have 30 minutes. So that is going to be 30 minutes out of 60 minutes. And if you type that into your calculator, it comes out as 0.5. Now for these questions, you can use a calculator to do these conversions, but just be aware that sometimes, potentially with a 0.5, that's going to be potentially a question that would be non-calculator. So you do need to know how to convert some of the easier ones, because you could simplify the fraction, which would become 3 over 6 and then 1 over 2. So it's not too bad to turn that into an hour. But for this one here, we need to do 40 divided by 0.5, and that is going to come out as 80. So we have an answer of 80, and that is in kilometres per hour. So we would write kilometres and then slash hour, kilometres per hour. And that would be our final answer. So as you can see, for this question, we're going to have to use some speed distance time in order to think about these journeys. And on the next question, you're also going to see that we might potentially even have to complete the graph by using a speed, which means working it in reverse. So let's have a look at that question now and see this in a slightly different way. Okay, so as you can see, this particular graph is incomplete. So let's have a read and see about how we're going to complete this. It says here is part of Carl's journey from his house and back. Here is the distance time graph for part of his journey, and it says part of his journey because it's not been completed. So for part A, it says work out Carl's speed for the first 30 minutes of his journey. So we need to be careful again because that's not necessarily the entire line there, but in this case I do think that is going to be the full line as 30 minutes takes us up to this point. So that is for his full journey. So we're looking at the speed from the start of the journey, which is down here, up to the top of the journey where the other mark is. So obviously in order to work out speed, we're going to want to use our speed distance time formula, which again we'll write down in a formula triangle, and that is going to be speed is equal to distance divided by time. So we need a distance and we need a time. And again, we're going to write this in kilometres per hour, although it doesn't actually say to, so we could actually write this in kilometres per minute. But we're going to assume for all of these speeds, it's going to want it in that format. So in terms of the distance, that is a distance of 20 kilometres, which we can obviously read by looking just to the left here. So we have 20 kilometres as our distance, and we're going to divide that by, and let's just write it down here so we don't forget that number. It's 20 divided by the amount of time. Now again, this amount of time, as we've been told in the question, was 30 minutes. So if we're going to write that in terms of kilometres per hour, then we're going to divide that by 0.5. Again, converting those minutes by doing 30 out of 60 and spotting that that's a half, or typing it into your calculator. So 20 divided by 0.5, and again we can type this in on the calculator, it comes out as 40. A half fits into 1 twice, and therefore it doubles your answer, so it fits into 20 40 times. So just a quick way of dividing by a half if you don't have your calculator on you. So that's our answer for part A, and again that was in kilometres per hour. So we could write that as kilometres per hour. On to part B here, it says Carl spends 15 minutes at the shops, and we can see that on part of the journey. So if we get rid of this, we'll highlight that point, and as you can see, he spends 15 minutes. You can see that each of those squares is 5 minutes down the bottom, so we're happy with that. That is completed as being the 15 minutes. It says he then travels back to his house at 60 kilometres per hour, and to complete the travel graph. So actually what do we need to find here? Well, we need to find the time it takes him so we know exactly what time it's going to finish. For example, down here, we're at 45 minutes. Now if it takes him 10 minutes to get home, he would finish here at 55. And we could connect our line using a pencil and a ruler and complete our distance time graph. But we actually want to figure out the exact time there. So at the moment we're at 45 minutes, but how are we going to figure out the time? Well, it again comes back to our speed distance time formula. And you can see if you look just at the top here, that if we cover up time, then time is going to be working out by distance over speed. So we want to get the distance and divide it by the speed. And that's quite good because we've been given the speed in the question and the distance we already know because we've got it over here, it's 20 kilometers from his house. So we need to do the distance, which is 20, and this is for part B. And we're going to divide that by the speed, which is 60. So 20 divided by 60. And if we do 20 divided by 60, what answer do we get? Well, 20 divided by 60 is going to come out as a third. So how are we going to interpret that in terms of a time? Because that is in hours. So 20 divided by 60 comes out as 1/3. Now, this is the difficult part for these questions because you have to remember that that is in hours and we want it in minutes. So what is 1/3 of an hour? Well, 1/3 of an hour we can work out. We could do that and we can do the working out to the side because we've got 60 that we want 1/3 of. And 1/3 of 60 you can work out in two different ways. Either you could just straight away times that by 60 on your calculator. So just type in times 60 once you've got your third value and it will come out as 20. Or you could actually work it out using a fraction of an amount and you could do 60 divided by 3. Again, that comes out as 20. So the working out here, we want to get a distance there that ends after 20 minutes. So at the moment we're at 45 minutes and 20 minutes on top of that is going to take us to 65 minutes. And again, you could write that down. I'm just going to write down that it was equal to 20 minutes. So we have the working out down because you always want to make sure you show your working out for these questions. So again, you want to get your pencil and a ruler and you just want to connect that up using a nice straight line. And that would complete this distance time graph. Now you don't have to get rid of all of your working, but just make sure that that doesn't get confused with any of the other lines. You don't want lots of lines drawn on there as it might get confused with the actual line that completes the graph. So there we go, that would be how we would complete our graph. Now obviously the difficult part on this question was that completion part. So let's just run over that again. So we spend 15 minutes at the shops and then travel back at 60 kilometers per hour. So we took the distance, which we got from our formula triangle, and we divided it by speed. 20 was our distance from home, 60 was our speed given to us in the question, and that came out as 1/3. That was in hours, so we multiplied it by 60 because there are 60 minutes in an hour, and it gave us our 20 minutes. Because down the bottom it was in minutes, that allowed us to then draw 20 minutes on top of our 45 minutes, which allowed us to complete the graph. So hopefully you're okay with that. Obviously this is the most difficult part of it, so it was worth talking about that again, but let's have a look at a question for you to have a go at. Okay, so your question. Now obviously this is going to be quite difficult for you to complete the graph, but there are two elements to this question that you can do. Part A asks you to work out the average speed on the first part of the journey where it is moving just up here. So you should be able to trace your finger down the graph to see what times that ends on. Part B, it does say to complete the travel graph, but it also asks you to work out the average speed on her journey home. So you should be able to do that without drawing the graph, and then you should just be able to imagine where the graph ends. Does it end here? Does it end here? Does it end here? Or where does it end? So for this particular question, obviously you're not going to be able to complete the travel graph and draw it on screen unless you're happy to draw this out for yourself, but you should be able to answer the question and know where you would draw it if you did have this in front of you. So pause the video there, have a go at this question, and we'll go over the answer in just a second. Okay, so for this question then, it says Jane travels 20 kilometers from her house to a friend's house. She spends some time there before returning home, and here is the distance time graph for part of her journey. Again, it says part of her journey because it's not completed. So work out Jane's average speed on her journey from her home to her friend's house. So from her home it starts down here, and that part of the journey ends just up there. And that is a distance of 20 kilometers, as we can see from the side of the graph. So again, we're going to want to use speed distance time in order to work this out. So if we draw our formula triangle, and I always draw this for every question if you want to use the triangle. So for this bit, now we need to find what bits of information we have and how we're going to type that into our calculator. So if we're working out the average speed, that is distance divided by time. So for part A here, we already know that we have a distance of 20. So we have a distance and we can put that in. For the second part here, we need to get the time, and we can get the time from the bottom. Now that ends at 10:40 and it started at 10 past 10. So if we label this on, that bit there was 10:10, which we can just about fit in. So that time there is a time of 30 minutes. So that is a time of 30 minutes, which we can label on the graph. And again, we're going to want to put that into hours. So hopefully you remember 30 divided by 60 comes out as 0.5. So again, this comes out as a 0.5, and you will see that these 0.5s are pretty common in these questions. But of course, you know how to approach it if you don't, or if it's not a 0.5, because you know that you can do the minutes divided by 60. So for this bit here, let's do 20 divided by 0.5, and that comes out as 40. And again, we had a number similar to that in a previous question, but that is going to be 40, and that is in kilometres per hour. So again, we're going to label the units there as kilometres per hour. And there is the answer to part A. If we move on to part B, we had some information first. So it says Jane returned home at a steady speed and she arrived home at 11:50. So for this particular question, it actually told you where the journey ended. So 11:50, we can label it just down here, and we can connect that up using a ruler and a pencil to make a nice straight line to finish off this journey. So all you had to figure out for this question was her average speed on her way home. So it says complete the travel graph and work out Jane's average speed on her journey home from her friend's house and give it in kilometres per hour. So again, we had a similar process. We needed to work out the time because we already know the distance is 20. So if we work out the time, if we go down our graph here, you'll see that she leaves her friend's house at 11:10. And she arrived home, as we've been told, at 11:50. So that is going to be a time there from 11:10 to 11:50, which again we can label just down here. That is a time of 40 minutes. So if that is going to be 40 minutes, this time it's not going to be quite as easy because obviously we're not going to have that 0.5, but we have the 40 minutes. So to work out average speed, we're going to do the same formula, and that is going to be distance divided by time. So for part B, and we can find some space to fit this in, we'll have to draw it over the top of the graph. For part B, the distance there is 20, and underneath we have to do the time of 40. But of course we want to give our answer, as it says in the question, in kilometres per hour. So we don't want to divide that by 40. Instead we want to divide it by the amount of hours. So to work that out, we could do 40 divided by 60, which comes out as 0.6 recurring on the calculator. So not very nice because now we have a recurring decimal. But that's fine because we just need to do 20 divided by that number. Again, there are other ways to approach this, but that's nice and easy for us to do in a calculator. We just have to do 20 and just click divided by and use the answer button. Or you could type in 0.6 recurring. Now if I type that in, 20 divided by 0.6, again you'll have to be able to use your recurring button, and if you press equals, that comes out as 30. So the answer there is 30, and that is again kilometres per hour. And there we go, that would be our final answer. So again, you could think about if there are other ways to do this. So is there another way of getting that answer without using that 0.6? Well, you could have typed in 20 and divided it by the amount of minutes, and then you could have thought about obviously changing it from there. But I think this is probably the easiest way in order to do that because it gives us that nice answer of 30. So if you had left the amount of time there in minutes rather than hours, you could have done 20 divided by 40. Now that would have given you half, which is related to the actual speed. Now obviously because that is in minutes, we would have to turn that back into hours. Now when you are doing this in reverse, you then have to multiply it by 60, and 1/2 times 60 also gives us the speed of 30. But now we are learning two different methods, and I think it's probably best that you stick with one method when you're doing this, but just being aware that you could actually use a different method there, and you could divide in minutes and then convert your speed back into hours. So that's fine for you to do as well, but just so you are aware, there is another method that you can actually use, and if you prefer to use that, that again is absolutely fine. So lots of different ways that you could approach these questions, but hopefully that was obviously useful and helpful for you. If it was, please like, please comment, please subscribe, and I'll see you for the next video.